So while the car's in storage, I've been playing around with the instrument cluster trying to get my dash gauges to work as per the original car. And I've purchased this second-hand dash gauge and I've been hacking it around a bit and getting the temperature, fuel and the missing oil pressure gauge to work are pretty basic PWMs. We're driving those from the SparkFun MOSFET board there, and an Arduino Uno doing the processing. Getting the tack to work was a little bit more complicated, but as it turns out, the NB Miata is pretty much the same as the NA Miata. Even though the drivers for the gauges themselves are a little different. So to get that to work, we had to put in an inducting coil, which I've taken out of a relay. I've hooked the relay contacts out of that, otherwise it makes a really interesting sound when you're driving it at 20 or 30 hertz and ramping it up. So the circuit diagram for that is there, and the 5-volt square wave obviously coming out of the Arduino into the MOSFET. Excuse me if that symbol is not entirely correct, but doesn't really make much difference to me. So the 12-volt supply straight from a computer power supply, and that actually plugs straight into this SparkFun MOSFET board, which is quite cool. That by default gives you the 12 volts and the 5 volts, but if you wire it up differently, the 3 MOSFETs on the left hand side can be 12 volt drivers as well. So I'm not going to bother showing you the fuel and temperature gauges, etc., but if we just turn on the board here, we can see the Arduino is driving the gauge up and down. At the moment I'm just using the basic tone command out of Arduino and running that between 30 Hz, which is its minimum, and approximately 265 Hz to get to 8000 RPM. So you'll notice it does a little kick here and there, and I'm not 100% certain why that occurs. Some cleverer people out there than me will no doubt have some ideas, but I'm going to carry on with the programming, and I'm going to try driving the frequency directly rather than relying on an inbuilt function. So we'll see if we can A, smooth that sweep out, and B, get any frequency under 30 Hz, which will be the 0 to 1000 RPM on the gauge. So stay with me. So running the whole dash cluster here, we got the Arduino Uno and the Seed Studios canbus shield. Stack us up on top of there, and then on top of that we have the SparkFun MOSFET board. So long-time EVTV viewers might recognize this. Looks very familiar, and in fact it's all the same components that I forget the guy's name, but the guy up there in Michigan or whatever put together for Jack. Anyway, my programming is obviously a lot more simple. It only has one job to do in my car. It doesn't have to be repurposed into other people's cars. So like I said, very cut down code. So we've got the CAN bus connection here and a little twisted pair, and another Deutsch connector going off to the HP EVS harness. This rather dodgy looking bit of wiring here goes to a speaker, and that's a little bit temporary at the moment, but that speaker will activate and warn me of a ground fault detection error. so I may be able to make it notify me of a few other bits and pieces as well quite easily. So there we go. Just 6 channels out of the MOSFET board. I need one for the temperature gauge, one for the inverter temperature gauge, one for the fuel gauge. Taco will be running directly from pin 2 output on the inverter. Another output for the speaker, and 2 more spares for not quite sure what just yet. I do have an eco button on the dash, so one of them may turn that on as well. And of course the low charge or battery warning light, so that adds up to 6, so we'll see how we get on. So another part of the whole conversion process, I decided it might be nice to do some custom gauges. So here is basically what was my existing dash cluster, and actually what it is my original gauge faces put on a spare cluster I've been hacking about. And I contacted a guy called Adam at Rev Limiter, and what he's done is he's designed me a nice set of custom gauges, these replaceable faces. So he's sent me a nice little set of these gauge faces. So there's a new tacho, a speedometer, and gauges for motor temperature, state of charge, and inverter temperature I've decided as well, and well, basically an on-off switch, or an indicator to tell me the state of the vehicle. Turns out that particular one is too opaque to let the 3-color LED shine through, which is a 12-volt 3 color, so it's red, green, orange, and that fits nicely into the little socket left here by what was an unused socket on my dash cluster, but I've modified this to just fit that in, and it drops in there quite nicely. If I can, yeah, there we go. So that just pushes in there, and once I push the deckle into place over the top of that, that'll hold that in nicely. I'm currently laminating up a new clear version of the on switch, so I've got some versions I did here. I've got 4 sets of each, so I'm going to laminate them up. That's just drying at the moment, so I'll see which one looks nicest in the cluster and fills in the holes best. But so that's my old mock-up thing I'm playing with, and I have the real one right here. And eagle-eyed MX5 or Miata owners would notice that I've moved the fuel gauge from its original position, which was here, up to the middle center, which I think that's probably the most important gauge on an EV personally. So also what I've done here is I've incorporated a light for the eco button or the eco indicator from the Curtis controllers, and the on-off indicator go up there again. Once I get that in the car, I'll be able to put the needles on and set everything into its correct position, but in the meantime I think that's looking pretty fantastic. I sourced some new LED cluster lighting, and I got some colored ones for the high beam and the eco and the ABS lights, so they look amazing. But the lighting, just at night, this thing lights up gorgeous. It's absolutely beautiful. So I hope to bring you some images of that before too long. And when that all gets buttoned up and snapped down, we'll have the cluster face over the top, sort of hiding everything, dressing everything up. So I think that's going to come together beautiful. So we'll carry on. So I've carried on, and I've got my new homemade on-off button deckle made here. This is 2 layers of overhead transparency film printed on the front layer. I've got 2 layers of Scotch tape stuck on the back, which makes it a little bit opaque, intending to diffuse the light through it, and then another layer of OHP film laminated on the back. So that's going to go over the 3-color LED, which I've sort of put in place here. I'm going to put a couple of black O-rings in the front, and this will trap everything together once the front deckle goes on and presses down on these pins here. Something I didn't mention earlier was that the gauges in the car, initially this is the fuel gauge, this was an oil pressure gauge, and this was a temperature gauge, as it still will be. They're basically the same construction, but all 3 gauges operate differently. So what I've had to do, I've dismantled the backing, and I've taken the whole coil driver of the fuel gauge and reassembled it onto the back of what was the oil gauge deckle up the top here. Then from the spare dash cluster that I showed you before, I've actually taken a second temperature gauge mechanism and put it on the back of this thing here. So these 2 temperature gauges work correctly as temperature gauges, and this one works correctly as a fuel gauge, i.e. extremely slowly reacting to any changes, which is good. I mean, we're not going to draw down 16 amp hours of battery inside of 2 minutes. So this gauge up the top here is intended to be run eventually off a JLD 505, which I may pick up at EvCom this year, I hope. So that's my plans. The car still does have a JLD 404, but long term what I'd like to do is to make the fuel gauge up here the primary indicator, and talk to some clever people about maybe interfacing the canbus information into a display on an Android head unit stereo or something. At the moment the car does not have a stereo, and it would be quite nice to have the tunes in an open top car. The canbus, I'm expecting to be able to put messaging from the 505 onto the HP EVS canbus, which I'll be picking up on my Arduino Uno and canbus board, and that with the relay drivers and everything, that will operate all of these gauges and all of the indicator lights, etc., and of course the fuel gauge sweep. So that that canbus might also be able to be routed towards an Android head unit somehow. So if anybody's got any cool ideas on that, it's definitely a stage 2 project, but something I'd like to start thinking about if anybody's got any ideas. So I've installed my little button. It's all held in there with some O-rings and trapped behind the front fascia bezel. And so let's see how it works. We'll start off with the red. That will indicate a failure condition, like gas cap open. And then it goes to orange, which means all good to go, ready for start signal. And when the engine is on, motor is on, we go to a green. Now this complies with the New Zealand rules for our builds, which tells us we need an indicator to tell us when the vehicle is on, and that should do nicely.